Hello guys, welcome to Valeto's Maths Academy once again. I'm super excited about this class, simultaneous equations. Yeah, simultaneous equation is one of my most interesting topics because I love the way it works itself. Okay, we'll dive into the class right away. Our learning objective for this class is to understand what simultaneous equations are, solve equations using substitution and elimination, check your answers, then practice solving different problems. Then we're also going to engage with interactive tasks. Okay, I'd like to tell you right away that although we'll be looking at simultaneous equation by solving using substitution and elimination methods, but there are a lot of ways you can also solve simultaneous equations. First of all, let's understand what simultaneous equation is. Simultaneous equation are two or more algebraic equations or equations, right, with the same unknown variables and the same value of the variables satisfy all such equations. What I'm saying is that you have two unknown variables, for instance x and y. The values of x satisfy both equations. Simultaneous equation involve two or more equations, and the same value for x satisfies the two equations at the same time. The same value for y satisfies the two equations at the same time. That is the beauty of simultaneous equation. Okay, so like I said earlier, there are so many ways you can solve simultaneous equations. You can use graphical methods for solving by plotting on graph. You can also use substitution method. You can use elimination, Gauss-Jordan elimination method. Then you can also use determinants for solving simultaneous equations. When we talk of the Cramer's rule, I remember Cramer's rule or Saros rule. Or you can solve simultaneous equations also through expansion by minors. But this is not to frighten you, but just to tell you that there are so many ways we could arrive at the same answer. But for this class, we'll be looking at substitution method and elimination method. We all arrive at the same answer using whatever method you like. Okay, all right, so we look at example 1, elimination method. By elimination method, what they just try to do is to, since we have two variables, is to eliminate one of the variables right away and work on one variable first, then apply your solution from that variable in one of the equations, any of the equations, and get the second variable. No much talking, let's go in. So look at this equation. X plus y is equals to 8, and x minus y is equals to 2. This is a very simple simultaneous equation. So in elimination method, what you do, you think of what to do, the operation to carry out to eliminate one of the variables. Here, if we add both equations, it's going to eliminate y because y has a negative sign here. So if we add both equations, which is, when I say add, I mean x plus x, we add the left hand side of the equation together and we add the right hand side of the equation together. What we are saying is x plus x plus y minus y, minus plus is minus, is equals to 2 plus 8 plus 2. We are adding in order to eliminate y. So y can eliminate y here. y minus y will go. So x plus x will be 2x is equal to 10. And x is equals to 5. All right. So this x is equals to 5 can be substituted in either equation 1 or equation 2, any of them. So if we substitute it in equation 1, we're going to have, since they say x is equals to 5, we're going to have equation 1 is x plus y is equals to 8. So instead of writing x here, you change the x to 5. So this one will now be 5 plus y is equals to 8. And y will be equal to 8 minus 5. And y will be equals to 3. If you get this, you can check your answer. So we say, therefore, x is equals to 5 and y is equals to 3. Okay. So if you want to test your answers, you can come over here and say the original equation is x plus y is equals to 8. Remember, we said that the same variables has to satisfy the both equations. So we say x plus y is equals to 8, and the second equation is x minus y is equals to 2. So let's see if the value of x and y satisfy these two equations. The first equation is equal to 8, the second one is equal to 2. So if x is 5 and y is 3, then for the first equation, it will be 5 plus 3. Does it equal to 8? Yep. That satisfies that equation. And for the second equation, x minus y is equals to 2. 5 minus 3 is equal to what? 2. So it tells us our answer is correct. So this is what we mean when we use this is how we use elimination method in solving simultaneous equations. Okay. If we take another example, by substitution method this time, solve the equation y is equals to 2x and x plus y is equals to 9. Okay. In substitution, all we have to do is make one of the variables the subject of the formula in the equation. But for this example now, y is already subject of the formula here, and y is equals to 2x. So all we need to do is take this 2x and substitute it in the second equation, which is we now say in equation 2, we now replace the value for y as 2x. So we say x, remember we are picking equation 2 now, we say x plus y is equals to 9. So in substitute 2x for y in equation 2. Okay, so in doing that, we then say x plus 2x, which is y, is equals to what? 9. So 3x is equals to 9, and x is equals to 9 divided by 3 is 3. Okay. So now we have the value of x. We now substitute the value of x in any of the equation, either equation 1 or equation 2. All right. So if we use equation 1, they said y is equals to 2x. So we have the value of x now. So we need to get the value of y. So equation 1 is y is equals to 2x, 2 times 3, which is x. So y is equals to 6. Okay. So like the first example, you can test the solution to the two variables in both equations. If it satisfies both equations, then you know you're correct. If the values of x and y satisfies both equations, then your simultaneous equation is correct, has been correctly solved. Okay, So we have practice questions. All these are easy questions, but let me see. Let me make it a little. Let me give you something a bit complex. So, for instance, if you are given an equation like this, 2x plus 3y is equals to 8 as equation 1, and the equation 2 is 3x minus y is equals to 23. Equation 2. Okay, if you are told to solve this using elimination method, use elimination. Okay, so in elimination method, remember what we're trying to do is to remove one particular variable and reduce it, because there's no way you can solve a solution when there are so many variables. You work from the known to the unknown. You have two unknowns here, so you have to reduce the unknowns to 1, and then you can derive the value of the unknown, and with that you apply it in the original equations and derive the value of the other unknown. So if you have something like this, because here the coefficient of x and the coefficient of y is greater than 1. So in our previous examples, coefficient of x and y were 1, so it didn't need much calculations or much elimination problem. So if you have something like this, what you have to do is to keep track of your equations. This is equation 1, this is equation 2. We can create a new equation because we want to eliminate one of the values. And remember, in equations, whatever you do to the left hand side, you must do to the right hand side. Now we have 2x plus y plus 3y is equals to 8 as equation 1, and 3x minus y is equals to 23 as equation 2. Okay, now we can create a new equation because we want to eliminate this. We can say we'll multiply equation 3 multiply equation 2 by 3. So if we multiply equation 2 by 3, we're going to have 3 times 3x will be 9x, 3 times minus y will be minus 3y, 3 times 23 will be 3 times 23 will be 3 times 3 is 9, 3 times 2 6, 69. I think so, 69. All right, so we can call this equation 3. Okay, so now if you see equation 3 is now similar to equation 1 and equation 2, they are the same. So we can, instead of using equation 2, we're going to use equation 3 and subtract it from equation 1 in order to eliminate y. So we can then say 2x equation 1, we're adding, we're adding because this is minus, this is a minus sign here, so we're adding. So we can say 2x, it is addition that is going to eliminate this 3y, not subtraction. So we can say 2x plus 9x. Remember, we are doing equation 1 plus equation 3. So 2x plus 9x plus 3y minus 3y is equals to what? 8 plus 69. So if we do this, 3y is going to eliminate 3y. Then what we have here is 2x plus 9x will be 11x is equals to what? 8 plus 69. 9 plus 8, 77. Okay. And here x will be equal to what? 77 divided by 11 should be 7. Yep. Just get the idea. If I make arithmetic mistake, please let me know in the comment section. So I think x is equals to 7. All right. Now that we have x is equals to 7, we can substitute this value for x in either equation 1 or in equation 2. So let us pick equation 1. 2 into 7, 2 times 7 plus 3y is equals to 8. So instead of writing x here, we have changed it to 7. So if you observe now, we now have just one variable, one unknown left here, which makes it easy to solve the equation. Because when you have only one unknown in an equation, it's easy to take matching terms or like terms and find the unknown. So here, 2 times 7 will be 14 plus 3y is equals to 8. And then when we take our matching terms, we're going to have 3y is equals to 8 minus 14. Then y will be equal to what? 8 minus 14 is minus 6 over 3. And y is equals to minus 2. Okay, let's check our answer. Let's use the first one to check our answer. Equation 1, 2x. So we say x here. Remember, we have gotten x is equals to 7, y is equals to minus 2. Okay, so 2 into x, which is 7, plus 3 into minus 2. Does it give us 8? Let's see. So 2 times 7 is 14. 2 times 7 is 14. 2 times 3 times 2 is 6 minus 6. So 14 minus 6 is equal to 8. Satisfies the first equation. Then we'll check for the second equation to see if it satisfies it. 3x minus y is equals to 23. So let's see if it's going to, the same values will satisfy the second equation. Oh my god. All right, so 3x is what? 7. 3 times 7 minus y is what? Minus 2. Remember, minus minus is equals to plus. So we have 3 times 7, 21. Minus minus is equals to plus, plus 2. Does it equals 23? Yep. So there you are. So that's equation for you. I just wanted to bring up this equation, at least something a bit different from what we have on in our practice questions, so that you would know how to apply the elimination method if you do not have, if the coefficient of the unknown is greater than 1. Yeah, if the coefficient of the unknown is greater than 1, like in this case, all you can do is to look for a number to multiply either equation 1 or equation 2 to bring up a third equation that can be added or subtracted from one of the equations in order to eliminate one of the variables, one of the unknown. Okay, then after eliminating that variable, you substitute your value in either equation 1 or equation 2, the original equations given to you. Okay, this is very, very simple. Just all you need to do is pick up questions and practice and practice and practice, and you get used to it. It's the same format, no difference. All right. Okay, then by substitution, we just make subject of the formula. I don't know if we should look at one more equation using substitutions. Let me see if I can formulate the equation quickly, really fast for you. Okay, supposing I say, let's just create something. 2x minus y is equals to minus 4. Let's try to make it a bit complex, and we say 2x plus 2y is equal to 20. Let's try this and see. Okay, so if we have this as our simultaneous equation, this is equation 1, this is equation 2, I want to use substitution method. All you have to do is try to make one of the equations, one of the unknown, the subject of the formula in that equation, then substitute that into the other equation. From this equation, if we are to use equation 1 now, if we want to make y the subject of the formula in this equation, we can say from equation 1, we can say that 2x minus y is equals to minus 4. This is the same thing as if we take y to this side and take minus 4 to this side, this will now become 2x plus 4 is equals to y. Okay, so y is equals to 2x plus 4. All right, so now we have the value of y. The purpose of doing this is just to eliminate the having two different variables. So we just want to have a single variable. So we substitute 2x plus 4 for y. Since we have done it in equation 1, we substitute it in equation 2 for y in equation 2. So we now pick our equation 2. From equation 2, we have 2x plus 2y is equals to 20. So if we're changing the value of y, we then have 2x plus 2 into, what is the value of x, y here now? 2x plus 4. 2x plus 4 is equals to 20. Okay, and then 2x plus, this will now be 2x. If we are to expand this, 2 times 2 is 4x. 2 times 4 plus 8, right? It's equals to 20. So 2x plus 4x is 6x. Then 8 crosses to the other side, will now be 20 minus 8. So 20 minus 8 should be 12. 6x is equals to 12, and x will be equal to 12 divided by 6, which is 2. Okay, then so we have the value of x. Now we can now substitute 2 for x in either equation 1 or equation 2, whichever we like. So our equation 1 here is 2x minus y is equals to minus 4. Our equation 2 here is 2x plus 2y is equals to 20. So let's try equation 2. So we now have the value of x. So when we say 2 into 2, 2 times 2, which is x, plus 2y is equals to 20. So 2y, taking matching terms now, will be equal to 20 minus 4. So 20 minus 4 should be 16, right? So 2y is equals to 16 and y is equals to 8. So we have that y is equals to 8 and x is equals to what? 2. So let's check our answers, putting them in the original equation to see if they will satisfy the two equations. The first equation is 2x minus y is equals to minus 4. So we replace it with the values of x and y. So 2 times 2 minus the value of y is what? 8. Does it give us 4? 2 times 2 is 4. 4 minus 8 is equals to minus 4. So it satisfies the first equation. We try it in the second equation. 2 into second equation is 2 times x is what? 2 plus 2 times what is y? Y is 8. 2 times 8. Does it give us 20 in the second equation? Let's see. 2 times 2 is 4 plus 2 times 8 is 16. 4 plus 16, does it equals 20? Yep. So it's as simple as that. So I just brought up something a bit different to show you that it doesn't matter what the equation is. Once you apply the same process, you are going to arrive at a valid answer. So it doesn't matter if they make it 100x. The coefficient of x and y has no bearing on your solution or on the process. All you have to do is apply the same format, the same process. No matter the coefficient of x and y, you're going to still arrive at a correct answer. All right, that satisfies both equations. So that is for elimination and substitution. Please let me know your thoughts on the comment section. You can like and subscribe to this video so that more people will benefit from what we are doing here. Okay, so back to our interactive task. This is a true or false question. If x is equals to 4 and y is equal to 2, do x plus y equals to 6 and x minus y equal to 2 hold? Yes, no, true, false. Let me know. Fill in the blanks. Solve x plus y equal to 9 and x minus y equal to 3. So let me know what your values for x and y is. Then there's a multiple choice question. If x is equals to 2x and x plus y is equals to 12, what is x? Please stop running away from x. People, once they hear find x, they get scared. X is always very easy to find. Just find it using our formats. Okay, match equations to their solutions. You have equation A and equation B, so you match it to the solutions here, 1 and 2. Check your solutions. Solve 2x plus y is equals to 7 and x minus y is equals to 2. Then substitute your values to verify. Okay, simultaneous equations involve solving 2 variables. We already said that. This is a summary. Then you can use elimination or substitution method for solving simultaneous equation. Remember, I told you there are a lot of ways you can solve simultaneous equations, but you always arrive at the same answer. So it's always easier to stick to what works well and what is easy to understand. Yeah, I'm not saying that other methods are difficult, but for the purpose of this class, we're sticking to elimination and substitution. You can also use graphical method. You can also use what's it called again? Cramer's rule or Saros rule or expansion by minors. Yeah, there are a lot of ways you can solve simultaneous equations. Okay, yeah. So thank you guys for this class once again. Please remember to practice and practice. When you practice questions in mathematics, it builds your confidence. It tells you how much you have understood the topic. So please pick up any math textbook at all at your disposal. and do justice to simultaneous equations and linear equations. We have done that already. In our next class, we'll be looking at quadratic equations. I hope to see you there. Thank you.